Hi everyone, thanks very much for this opportunity. I'll be speaking about a systematic review that we have conducted to understand the meta-analysis methods that are used by systematic reviewers when they include interrupted time series studies. So we'll begin in the context of a systematic review that is investigating an intervention or exposure that might not allow for randomization. In the examples that you see here, randomization may not be possible or desirable, and so instead we must rely on non-randomized trial designs. The one that we're interested in is the interrupted time series. So in an example here, the researchers are interested in whether or not a mass media campaign impacts the number of monthly HIV tests. An ITS study requires that we have a clearly defined time point for the intervention or exposure, which is the date of the campaign's release in this example. And with multiple measurements both before and after the campaign, we can model the trend before the campaign, taking into account any correlation between measurements over time, which we call autocorrelation. And we can project this trend into the post-interruption period as an indication of what would have occurred in the absence of the campaign. This predicted trend can then be compared to the trend that was observed after the campaign's introduction. Using these elements, we can quantify the impact of the mass media campaign with a variety of effect metrics. Two examples are an immediate change in level, or the step increase or decrease in the number of HIV tests. And another is the change in slope, where the trajectory of the monthly HIV testing may change. In a systematic review, we may have several different studies that evaluate mass media campaigns, each of which may have a level change, for example, and we might want to combine the effect measures from each of the published studies so that we have just one overall effect of mass media campaigns. We can use meta-analysis to synthesize the evidence from these multiple studies, and this can be done in one or two steps, where a two-stage approach involves the analysis of the primary studies to obtain the required effect estimates in the first step, and then the combination of these estimates in the second step. In the one-stage approach, which Carla spoke about, both of these steps are performed simultaneously so that the analysis and the combination are performed in one step. However, there have been no reviews describing the meta-analysis techniques that are used in systematic reviews that incorporate results from ITS studies. So our systematic review had the following objectives. Firstly, the analysis of the primary ITS studies is critical for ensuring reviewers are pooling like with like. And so we are interested in whether or not the reviewers include ITS studies in their meta-analyses and whether they reanalyze these ITS studies. And if so, what are the ITS methods that are being used? And if not, did they provide the primary ITS study analysis in their review? At the meta-analysis level, what are the statistical methods used? And then what effect measures are being explored? Are the reviewers interested in level changes or perhaps slope changes? Lastly, are the risks of bias and methodological quality being assessed for the included ITS studies? So reviews were eligible for inclusion if they included at least 2 ITS studies or if they included 2 interrupted time series in a meta-analysis, and I'll explain this distinction in the coming results. We collected several hundred items from each of the included reviews, and these detailed the review characteristics, the ITS analyses, and the review's meta-analyses. Our search resulted in 54 included reviews that met our inclusion criteria. And in reading these 54 reviews, it became clear that not all reviews follow the same path, and that not all the factors that determine the pathways are within the control of the systematic reviewers. So for example, a decision made by a systematic reviewer may be that they wish to reanalyze the ITS studies. However, if the raw primary ITS data is unavailable, the reviewers may be limited to extracting the effect estimates. So we'll be discussing the results in the context of these pathways. So first of all, as mentioned before, reviews may combine ITS studies or interrupted time series, the former being the classical type of review, which collects published studies for inclusion in their meta-analysis, of which we had 34 reviews. However, we had 20 reviews where the meta-analysis was performed on interrupted time series, such as collecting ITS data from each province in Switzerland, for example, and combining the effect estimates from each of these series in a meta-analysis. Within the reviews of studies, the median number of ITS studies was 5, while the median number of ITS series in primary studies with multiple series was 12. In the reviews of studies, we found only 65% provided a definition of interrupted time series, and ITS studies were combined in meta-analyses with other study designs in 44% of reviews. We were pleased, though, with the frequency of risk of bias assessments in 97% of reviews. There were 51 reviews that performed a two-stage meta-analysis, which fall into pathways 2, 3, 4, and 6. And for these, we discussed the ITS analysis and the meta-analysis methods. At the ITS analysis level, 41 reviews performed their own analysis of the primary ITS studies or series. In the case of reviews of studies, the most commonly reported reason for reanalysis was so that they could be analysed as a time series, where the primary study may have used before and after analysis. Most performed a segmented time series analysis. 22% used an ARIMA model, which accounts for autocorrelation. And of those that did not use an ARIMA model, we unfortunately could not determine if or how autocorrelation was adjusted for in 25% of reviews of studies. And in 2 reviews, we could not determine how the ITS studies were analysed at all. There were 8 reviews of studies that simply extracted the effect estimates from the primary studies, and 2 reviews for which we could not determine whether they had performed a reanalysis of the ITS studies or extracted the effect estimates from the primary studies. For these reviews, we pulled out the details of the analysis that were described, and only half of the reviews mentioned autocorrelation. At the meta-analysis level, the most common effect measure meta-analysed was the immediate level change, which appeared in 82% of two-stage reviews. Slope change was not as common, appearing in just under 20% of two-stage reviews. Almost 70% of reviews used random effects meta-analysis, with the most common heterogeneity variance estimator being dersimonian and lead. However, in just under 30% of two-stage meta-analysis reviews, the heterogeneity variance estimator and the confidence interval method could not be determined. And in 2 reviews, we couldn't determine the method used for meta-analysis at all. Reporting of heterogeneity was often incomplete, with only 60% of meta-analyses from the 51 two-stage reviews having a reported measure of heterogeneity alongside their pooled effect estimate. We found only 3 reviews that used a one-stage meta-analysis approach, and all 3 were interested in the immediate level change only, and only 1 mentioned autocorrelation. So what have we learnt? First of all, ITS studies are being meta-analysed, and a range of methods and approaches are being used. But the most common approach was the 2-stage meta-analysis using dersimonian and lead and wald-type confidence intervals. We found that the reporting of the included study designs must be improved, and the statistical reporting or the reporting of the statistical methods that are used to analyse ITS studies also needs improvement, regardless of whether the review is conducting a reanalysis or reporting on the methods used by the primary study authors. The meta-analysis method reporting requires improvement, in particular, the details regarding the methods accounting for heterogeneity. Our systematic review has several strengths, the key of which was our extensive data extraction. As for limitations, determining whether a review met our inclusion criteria was much harder than expected. Given that reviews often did not include a definition of ITS studies, we struggled to determine if ITS studies were included in the reviews at all, and subsequently if they included a meta-analysis, and then in which meta-analysis had the ITS studies. So to conclude, this systematic review indicates that reporting in reviews of ITS studies should be improved. This is in terms of reporting the inclusion of the ITS studies, the analysis methods used for the ITS analysis, and the methods for meta-analysis. This becomes particularly pertinent given the recent events that have featured many interrupted time series and the meta-analysis of these ITS studies across the world. So thank you very much for your attention, and to my amazing team. It's been a pleasure to speak this evening.